Hi, my name is Phak Nguyen from R&D Center at VinCSS, a subsidiary of Vin Group. After years of researching and developing the FDO device onboard mechanisms, today I would like to introduce to you our VinCSS FDO device onboard ecosystems, which is being called VinCSS IoT platform and its basic deployment. This short video will quickly cover FDO, its benefit, and several demos on 3 system-on-chips, SoC, including STM32, ESP32, and Raspberry Pi. FDO is an automatic onboarding protocol for IoT devices, which permits lay binding of device credentials. Without modifications, one manufacturer device can securely onboard and interact with many IoT platforms.
Let us deep dive into the FDO benefits. FDO is a zero-touch onboarding. It is easy to set up and require no special skill set. It is fast, secure, and supports a wide range of hardware, from ARM MCU to industrial-graded processors. FDO also supports both cloud and on-premise infrastructure. FDO allows late binding of device credentials, allowing the device owner to select IoT platform in later stage of the device life cycle.
Our FDO ecosystem currently includes VinCSS IoT platform and various FDO clients for the following SoCs. STM32, a family of 32-bit microcontroller based on ARM Cortex-M processors, which will be deployed via Ethernet. ESP32, a feature-rich microcontroller integrated with Wi-Fi and Bluetooth for a wide range of applications, will be deployed via Wi-Fi and Bluetooth. Raspberry Pi, a small single-board computer integrated with trusted platform module, which will be deployed via Wi-Fi. VinCSS successfully implemented the following: the DI server, device initialize server, the RV server, rendezvous server, and the owner server, which are running on Node.js. We also provide Golang server module and Python or C client module. Client, which runs on user device, is based on Intel FDO client with ECDSA extensions, elliptic curve digital signature algorithms with TPM, trusted platform module, port to ESP32, and also supports high silicon microchips, embedded Linux. DI server is a server which initializes necessary information for FDO process. Supply chain platform is an internally built-in device management platform from manufacturers. It is a web user interface for manufacturers, distributors, and sellers to manage devices which are initialized via FDO protocol, store ownership vouchers, and extend such device ownership to other users. RV server acts as a rendezvous point between the newly powered on device and the owner onboarding service. Owner server transfers the control of the device to the owner managers and never interacts with the device again.
Here are the 6 summary steps on FDO flow. Manufacturer, package, FDO enable devices and manage ownership vouchers. OV, that represents the ownership of the devices. Manufacturer, ship FDO enabled devices along with files that contains ownership information called ownership voucher to their buyers. The buyers then submit the ownership vouchers to FDO supported platform, in this case VinCSS IoT platform, to declare their ownership information. The FDO platform then connects to a rendezvous server, RV, and transfer the ownership information of the OV to RV and wait for the devices to be powered on. After that, the buyers power up the devices. When the devices run for the very first time, it will connect to the RV, which the FDO platform already connected, and transfer the ownership information, then transfer the device information of them to it. At this time, the RV will verify the ownership information, matches the device information, then it will let the FDO platform connect directly to the devices. Finally, the FDO platform provisions and authenticates the devices, and the FDO process completes successfully. Last but not least, the devices are ready for services such as auto download, configurations, required app, and certificate.
IoT platform is a web user interface for the owner to manage the devices by patching security vulnerabilities, installing or updating software, retrieving sensor data, interacting with actuators, etc. IoT platform support FIDO2 login. FIDO2 is a passwordless authentication created by FIDO Alliance to require better authentication standards for passwords and login. In IoT platform, we have ownership vouchers, which is used to transfer digital ownership credentials from one owner to another without the need to power on the device. The private key, which is associated with the owner public keys in the ownership voucher. Also, we have other configuration module for FDO, for example, connect to a private network. Here are our demos on 3 system-on-chips mentioned previously. First, log in via WinCSS FIDO2 passwordless authentications. Next, add necessary information to initialize FDO process on WinCSS IoT platform. Finally, new owner will load the newly created vouchers on WinCSS IoT platform to the device, ESP32 Wi-Fi, ESP32 Bluetooth, STM32, Raspberry Pi with TPM. Progress status can be seen on both the device test screen and WinCSS IoT platform dashboard. WinCSS IoT FDO brings many benefits. It is easy to be installed, even for users who are not knowledgeable about information technology. It also plays an important role in safety, security, and privacy. In addition, WinCSS IoT FDO is convenient, quick, and easy to deploy on large scale. This year's WinCSS announced partnership with Havana, the leading security camera designer and manufacturer in Vietnam, to integrate WinCSS IoT FDO into the production of smart security cameras with the highest level of safety, thereby minimizing the risk of data leakage and cyber threats from these devices. We want to thank FIDO Alliance for the FIDO device onboard specifications. Thank you Intel for your open source code. It is a good reference which enables us to build our complete solution. If you have any questions or suggestions, do not hesitate to contact WinCSS via the email address on this screen. Thank you for listening.